These are all terms that should be familiar to you. You should have talked about these kinds of triangles before. Equilateral triangles, all three sides are the same. Isosceles has two sides the same, and scaling has none of the sides being the same. We got a right triangle where we have one right angle. We have an obtuse triangle where we have an obtuse angle. They're pretty self-explanatory. Our plan for this week is that this has more notes than usual. And so I'm going to focus a lot on getting through, and I want to get through as much of the notes as possible for this week, so that when we go into remote next week. So I'm basically doing kind of what I would usually do is this would be like 2 weeks worth of notes, and I'm doing them in one, so that next week you can start with some, ease you in with some stuff that we already covered while we were here. So I'm going to start notes today. I'm going to do more notes tomorrow. And then I'm going to do one more day of notes on the Wednesday, Thursday. So you'll need to tune in tomorrow. We'll finish up the notes on Wednesday. And the assignment for this week is going to be to have all these notes done. There's also going to be some problems within these notes that I'll check for you to practice on your own and for you to try on your own. That being said, we're going to skip the rest of the first page, so you don't need to worry about it. We're going to move on to the top of page 2. Because the focus of this chapter, we're starting a new chapter here. The focus of this chapter is going to be congruence and congruent shapes, mostly congruent triangles. And so when we talked about sides and angles being congruent, measuring the same. It still means the same for an entire shape to be congruent. If an entire shape is congruent, that means that all of the measurements are the same. So for example, a triangle is going to have 3 sides and 3 angles. So that means all 3 pairs of sides in this triangle are congruent, and all 3 pairs of angles in this triangle are congruent to each other. So each side and each angle has a matching pair. And that's marked by the tick marks here. So I have 1 pair of tick mark for the first pair of sides, 2 pairs of tick marks for the second pair of sides, 3 pairs of tick marks for the third pair of sides. And same thing for the angles. First pair of angles has 1 tick mark, second pair of angles has 2 tick marks, and you'll never guess what the third pair of angles has. It's 3 tick marks. So each new pair of congruent things needs to have a different pair of tick marks to go with it. Because if we just put 1 tick mark on everything, that would mean that all 6 sides were the same, which they're not. So once we have a new pair of sides that match up, we need a new pair of tick marks to go with it. And if these shapes are congruent, we can write what's called a congruence statement. Now, we've already done these for sides and angles. They look like, angle A is congruent to angle B, or something like that. So when we write these for the entire shapes, the key thing to remember is that order is important. Order is important. As soon as I have triangle ABC, we want to write that it's congruent, and I want to match up my sides the way that they should be matched up. So I want A here to match up with F over here. Since those points match up. And then I want B on the top here. B matches up with E over here. And then the last one, C here, point C matches up and transfers over to point D on the other triangle. So C needs to match up with D. Triangle, the second triangle has to be written in this order, F, E, D. F, then E, then D. Any other order, and it's wrong. It's mixed up. By the way, another question I'm going to be asking, thinking about last week, is I just took this triangle and moved it, shifted it over to the right. Is that a translation, rotation, or reflection? If I'm just taking it and shifting it over. So shifting, any shift up, down, left, or right, in this case shifting to the right, that's a translation. So translating is shifting. And what we'll eventually do is we'll write out each as a translation, rotation, or reflection. So we'll do that with this next example as well. Translation, rotation, or reflection. Well, it's not translation. It didn't just shift over to the right because somehow S ended up down here. If I took and just flipped, then K would have ended up like up here. And so this has to be a rotation. This turned up here. So like point L rotated and ended up here. So the transformation that happened is a rotation. And we are going to write out the pairs of congruent corresponding parts. So that's going to be 6 pairs. I have 3 pairs of sides that match up, and I have 3 pairs of angles that match up. So I'm going to start with my pairs of sides. Here's my first tick mark. That is segment J to K. And my tick marks say that J to K, 1 tick mark should match up with 1 tick mark on the other side, which is down here. So that's going to be T out to S. We're matching up the tick marks. Next, I'm going to go to the side that has 2 tick marks. That is L to K. So segment L to K needs to line up. 2 tick marks should match up with 2 tick marks over here. L to K needs to match up with R to S. And last one, I have my 3 tick marks, which is J to L. And J to L, 3 marks should match up with 3 marks over here. T to R. So there's our 3 pairs of sides that have to be the same. So now we're going to do the same thing for the angles. We want 3 pairs of angles. I'm going to start again with 1 tick mark, which here is angle K. So what angle do we want to match K with on the other triangle? Which one has one mark over here? It's going to be S. K lines up with S. And we're going to do the same thing with the other two pairs of angles. So I want to give you 30 seconds to do that. All right. Finally, we're going to write a congruence statement for the triangles. So I'm going to pick an order for the first triangle. So again, the idea is that the order is going to matter. What that's going to mean is that my first triangle, I could get to choose an order. All right, so I'm going to go in order of how we did the angles. So I had K first, had one tick mark, then L had two tick marks, then J had three tick marks. So I'm going to go K, then L, then J. So I made a choice for the first triangle. But once I have made that choice, that is locked in. And I have to pick and keep my order consistent in the other triangle. So now that I picked K, L, J, I am locked in. And since I wrote K first, what angle did we say K lined up with? S. So since we wrote K first, we have to write S first. We have no other choice. L, we said, lined up with R. So we have to write R second, since L was second. And then J was last, so that means T is last. And the reason that this order matters, the reason that we're writing it this way, is so that I can show you this statement. I can show you this statement, and you can come up with all of these. In other words, hidden in this statement are all the angles lining up with each other. That K goes with S, that L goes with R, that J goes with T. Not only that, but for example, if I wanted to know what L to J was congruent to, well, L to J, last two letters, since I wrote it in the right order, last two letters are going to line up with the last two letters, R to T. So L to J should line up with R to T. And we said that right here. So I can look at this statement and know which pairs of sides and which pairs of angles go together. So let's practice doing that now. In the diagram, ABGH is congruent to CDEF. We're going to solve for x, and then we're going to find the measure of angle h. So first off, we need to know what angle h should be paired with. And I'm not even going to look at the diagram. I'm going to look right at the congruence statement up here. Because that's going to tell me I'm interested in angle h. That's going to tell me what h goes with. H is the last letter here. So last letter here should go with the last letter in the other shape, F. So that statement tells me that h has to match up with F. So since those are congruent, they're going to measure the same. So we're going to make those equal to each other. So h was the 4x plus 5. And what was f? F was 105. So those two should be equal. That's going to help us solve for x there. So we have 4x plus 5 equals 105, so I'm going to subtract 5 from both sides. We have 4x here equaling 105 minus 5 is 100. It's been a while since we solved an equation. 4x is 4 times x, so I'm going to get rid of times by dividing by 4 on both sides. X equals 100 divided by 4 is going to be 25. Since h should match up with f, we should be able to figure out what angle h has to be. But let's double check that our answer is right by plugging 25 in for x. So I got 4 times x is 25 plus 5. Let's see, 4 times 25, that's 100 plus 5. And so in what should come as not a surprise, we get 105 degrees, which, oh my goodness, it's exactly the same as the 105 over here. That's how we know we're right. Because those should measure the same since we said they were congruent. I'm going to give you the next one to try on your own. All right, I'm going to get you started. And I'm not going to look at the diagram here. I'm just going to look at, the only thing I'm going to ask you in the diagram is if we're solving for 2 variables, my tip for you was to solve for one of them first and ignore the other until you've solved for it. So I'm going to start by solving for x. I'm not going to worry about anything with y in it. I'm just going to worry about the stuff with x in it. So where is there something labeled with x in it? Well, it's that side down on here. It's q to r. So q to r is the side that's got an x in it. It's up on the top of the figure on the right. It's got a 2x plus 4. So we want to know what q to r lines up with. Well, q to r is the last 2 letters, so it should go with the last 2 letters of the other shape, which is what? F to g. There's your 2 sides you want to make equal to each other. That should get you for the solution for x. If you need some more help, I'll give you some time at the end of the hour if you have questions. But that should get you started on it. Next page. We're going to the next page. Third angle theorem. This says if 2 angles of one triangle are congruent to 2 angles in a second triangle, then the last pair of sides has to be congruent. So remember, I had 3 pairs of angles. If I have the first 2 pair of angles that I know are the same, that's going to lock in the third pair to also be the same. This doesn't work with sides, but it does work with angles. And it's because in every triangle, the 3 angles in a triangle have to add to 180 degrees. So this is because the 3 angles in a triangle add to 180. That is a rule about triangles. So as an example, let's say that I tell you in this triangle that this angle is 70 degrees and this angle is 50 degrees. Well, if I tell you that one angle is 70 and the other angle is 50, then we can figure out what the third angle has to be. 70 and 50, let's see, 7 and 5 is 12. So that's 120 degrees. I need to get to 180, so how much more do I need? 60. So that makes this other angle have to be 60. Over on the other triangle, I haven't written down any measures in the other triangle yet, but I know that because this is 70, this is congruent to it, so it also has to be 70. And then this has got 2 tick marks, so it matches up with angle A and is also 50. And guess what? Now I'm trapped. Because I know this is 70 and this is 50. That only leaves 60 as my choice for that third angle to be. And ding, 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 these two are the same. So because I have those two angles lining up, regardless of what triangle I'm talking about, I have 120 degrees so far, so I can only have 60 degrees for that third angle. It's locked into place. All right? So let's look at this in another triangle here. Here are the two triangles we're talking about. This one's a little bit trickier because the diagram is tricky. Here's my first triangle. And here is my second triangle. And the angle we're looking for is angle BCD. Or sorry, BDC. Angle BDC. Well, we can trace that out just like we always would for an angle. Angle B down to D, out through C. So we are looking for this angle here. Well, first off, let's write down some angles that we know. This is 45, which means, oh, there's one tick mark over here, so that's got to match it. This is 45, this is also 45. Here's a pair of 2 tick marks. So this angle here, 30 degrees, has to match up with this angle here, so it's also 30 degrees. Now, there's a lot going on in this diagram. A lot of different triangles overlapping with each other. So I'm just going to focus on the triangle that has the angle I want, which is the blue one. I'm going to draw it out separately, and that might be able to help you see what we're going to do. I want to know this green angle right here. Well, we just said that this angle over here was 30. And this angle up here was 45. So I got 2 of the angles, so now I can get the third because I can take 30 and 45, and then whatever this angle is, and those 3 angles, when I add them together, should be 180. 30 and 45 is 75. And then I'll just call this x, since I don't know it. So subtract 75. And we get x to be 105 degrees. So using the idea that that last third pair of angles has to go together, and angles in a triangle add to 180. And that relates back to figuring out which pairs of sides and which pairs of angles go together. So that idea of matching up pairs of sides and angles is the big idea of today. Let's start off one more. Find the value of x. This is another use of the third angle theorem. I marked this pair of angles being congruent. I marked this pair of angles being congruent as well, but I actually didn't need to. I can guarantee you that these two angles are together. Hey, those lines are intersecting. These angles are across from each other. I had a name from chapter 1. These are vertical angles. So these angles have to be congruent. Which leaves only one choice for the third pair of angles that line up. Since these two pairs of angles are congruent, the third pair has to match up with where? On the other triangle. There's only one choice. The other angles are taken. Only one that's available? 44. That's my only choice. So that means these two have to be the same. There's your equation. So I'm going to ask you to do this one, actually these two on your own as well. So finish up solving that equation. And this one is, the idea is going to look very similar to this one over here. And using that idea that the angles in a triangle add to 180. So give those a try on